All right, day 2 of semester final review, starting with exponents, okay? Multiplying and dividing exponents. When we multiply exponents with the same base, so what I mean by that, if I look at these x's, they all have the same base. With those exponents, we want to add those together, okay? But first, when you have a problem with all of this, you want to take it one at a time. So I want to multiply all my numbers together. What's 3 times 3 times 3? 27. Okay, now I want to do the x's. X to the negative 2, x to the second, x to the fourth. I want to add all those together. What's your final exponent? Negative 2 plus 2. 0 plus 4. 4. So you have x to the fourth. And then you still have y squared, so that just stays as y squared. Okay, let's look at 16. It's pretty similar. What do we want to do first? Yep, multiply the 2's. 2 times 2, 4. Next, you want to look at the x's. X, what's the exponent on the x? The first one. 1. Yep. And then we have x to the negative 1. X, 1 minus 1 is 0. Remember what anything to the 0 power is? Anything to the 0 power is just 1. So I'm going to write a 1 for now to replace those x's, because this was x to the 0. And then we have y's, y to the fourth and y to the first. So what's that exponent? 4 plus 1? 5. So then just simplify. We have 4y to the fifth. All right, let's look at number 17. This time we have a power to a power. So we have our parentheses here, and then we have this power on the outside. What are we going to do with that power? Yep, you're going to distribute it into both of those powers. Okay, so are we adding or are we multiplying? Multiplying. So my new x exponent is 6, y is 9. Yep, and you get that from multiplying. Power to a power, you multiply. Okay. I'm going to look at number 18. Same thing, power to a power. What are we doing? Distribute. What happens to the, if it goes to the 2? Is it 2 times 4? It's 2 to the fourth power. Okay, and then what's my new x exponent? Negative 16. Okay. 2 to the fourth power is what? It is 16. What do we do with negative exponents? Can we have them? No. How do we fix them? Yep, it goes to the bottom. So we have x to the 16th. The 16 stays on the top because it has nothing to do with this negative exponent right here. That's why the 16 stays on the top. So the only things that move are if they have negative exponents. Everything else will stay. Okay, let's move on to dividing powers. Okay, with multiplying powers of the same base, we added the exponents. What are we going to do when we divide? We're going to subtract the exponents. Okay, so I'm going to look at the a first. We have a to the third and a to the fourth. So 3 minus 4 is negative 1. Okay, rip, top minus bottom. Okay, and then do we have anything to go with this b? No, so it's going to stay where it's at. Can I leave my answer like that? No, what do we have to do with that a to the negative 1? Yep, put it to the bottom. Does the b stay on the bottom? Yes. So what do we have on the top now? Yep. So it's 1 over a times b. Okay, let's look at one that can get a little more complicated on these. Just like when we did with multiplying, you want to take everything one at a time. Okay, can we simplify 4 divided by 3? No, so I'm going to keep 4 over 3. Remember, I'm going to treat them as their own fraction right now. Now our ends, what are the exponents on the ends right now? 1. So 1 minus 1, 0. Anything to the 0 power is 1. Okay, and then what about the m's? What do we do with this m to the second? Keep it on the top or the bottom? On the top. Yep, so we have m squared over 1. You think that is 1 over 1. Okay, now put it all back into one fraction. Do we have to flip anything or worry about anything? No. So all you do at this point is just multiply straight across to write your new fraction. So we have 4m to the second over 3. Look at 21. So here, this is where order of operations comes into play. So on this one, what do we need to do first? Distribute that 4, yep. So what's my new exponent on the y? Y to the 12th, and then we still have our x cubed y to the negative 4th. Am I done? No, now we have to multiply powers of the same base. I always go in alphabetical order, but that's just me. Okay, can we do anything with this x? No, so I'm going to keep it. And then what about the y's? What do we do with those? Add the exponents. So 12 plus a negative 4, or think 12 minus 4 is 8. Okay, move on to 22. Anything to the 0 power is 1. So what happens to this whole thing right here? It's to the 0 power, so that whole thing is just 1. And then we still have 2x squared y cubed. Can we really do anything else? No. So your final answer is just that 2x squared y to the 3rd. So whenever you see anything to the 0 power, it's automatically 1. Okay. Okay. Let's look at 24. What do we want to do first on 24, do you think?
Combine like terms.
Where at?
On the bottom.
Yep. You want to see if you can simplify the top or the bottom first. Can we do anything with the top? No. So I'm going to keep the top. And then the bottom, we can simplify. How do we simplify the bottom? Yep, we're going to multiply all of them together. So remember, take your numbers. What's 2 times 3? Times 2?
12.
So we have 12. Do the same thing with the a's. 3 plus 2 plus 0. So a to the 5th. And then the b's, we have 3 minus 2, which is 1. Yep. Are we done? No. Okay, we simplified the top, we simplified the bottom. Now we have to compare top to bottom. So take everything one at a time. Can we do anything with 4 and 12?
Yes.
What?
Divide the 12 by 4. Divide
Yep.
4 by 4.
Yep, how many times does 4 go into 4? 1. How many times does 4 go into 12? 3. Okay. What about the a's? Keep them on the top or the bottom? Keep it on the bottom. And then what about the b's?
Subtract.
Yep, we're going to subtract the exponents. So we have 2 minus 1. 1, does that go on the top or the bottom? Top. Yep. And then lastly, just combine your fraction as 1. So we have b over 3a to the 5th. 26, again, we have a fraction, so we want to simplify the top and the bottom. Can I do anything with the top? No, so I'm going to keep the top. And then what do I do on the bottom? Yep, take that negative 4 power into both powers. So what is my new a exponent? Negative 8. My new b exponent? Negative 12. Okay, keep simplifying. Can I do anything with the 2? No. So 2 is going to stay. I'm going to treat it as 2 over 1. What about the a to the negative 8? It has to go on the top to make it positive, so we have a to the 8th over 1. Okay. What about the b's? let's subtract first. So we have 1 minus 12. Sorry, 1 minus a negative 12. Yep, 1 minus a negative 12, which does give you a 13. Where does that go, on the top or the bottom? Top, yep. Good. So then just create your one fraction. 2a to the 8th, b to the 13th. So if you ever get a bunch of negatives going on and it gets confusing, go ahead and write them off to the side so you can see it. So in dealing with these functions, they're exponential functions. What are their graphs going to look like? There's two options. Remember, there's exponential growth and exponential decay. Yep, so it could either look like this or it could look like this. Okay? Do you remember how you can tell the difference?
No.
What's this one going to look like? Is it going to be growth or decay? It's going to be growth, okay, because we have that whole number in there. What about this one? Well, let's see. Remember, you have to do these with the XY table. Do you remember what values you pick?
1, 3, 5, 7.
That's for the step pattern. Do you remember what values you pick for XY table?
-1, -2, -1, 0, 1, 2.
Yep, you want some negatives, you want your 0, and you want some positives. Okay, so all you're doing is plugging in these values. Again, if it helps you write it out, do that. Okay, so we have y equals 3. I'm going to start at the top to the -2. Can we have negative exponents? No, so where does it go? 1 over 3 squared. What's 3 squared? 3 times 3? 9. So we get 1/9 for the -2. So then if I plug in -1, again, can we have negative exponents? No. So we have 1 over 3 of the first, which is just 1 over 3. Again, anything to the 0 power is 1. And then 3 to the first power is 3. 3 to the second is 9. So then last thing you have to do is just go plot those on the graph. So there we got exponential growth. Quick. Let's see what's going to happen to this one. So same XY table, same values. So we have -2, -1, 0, 1, and 2. So same thing, plugging in those separate values. We have y equals 1/4 to the -2nd. What do we do with that -2nd power? This is something we didn't talk about on the front page. What do we do with that -2nd power? We're going to distribute it to the top and the bottom. So we have 1 to the -2 over 4 to the -2. So here, can I have negative exponents? No. So I want to do what? Flip them. So we have 4 squared over 1 squared. What is my final value? 16. Yep. 16. Let's do the same thing with the 1, -1. So again, you're going to distribute that exponent into the top and the bottom. And then you're going to flip it. So your final value is 4. Anything to the 0 power? 1. And you should see a pattern happening. What is my value for 1? 1/4. What's the value for 2? 1/16. Yep. So what happened to this one? Decay. Yep. Okay, so looking at these two compared to each other, how can you explain the difference to me of exponential growth and exponential decay?
Growth goes up to the positive side.
Growth goes up, decay goes down. How can you tell me at the beginning whether it's going to be growth or decay?
It's not growth.
Right. If we have a whole number, like on 27, it was 3 to a power. Okay, that's a whole number, so it's going to be growth. Okay. 28, it was a fraction, so that is going to be our decay. On these two, did they ever go below the x-axis? No. Would they ever go below the x-axis? No. Okay, so same thing, xy table. Okay, if I plug in -2, okay, comparing to what we got on the backside, we ended up getting 16 to this, but we still have that -1. So 16 minus 1 is 15, so that's your -2 value. What would our -1 value be if you compare it to the table we just did? 3. Anything to the 0 power is 1. 1 minus 1? 0. Okay. Now we have 1/4 minus 1. What would that give us? Would give us -1/4. And then we same thing with the 1/16 minus 1. So you see how it's kind of changing? So you do it the same way we were doing on the front, but then you have that extra part that's changing. With this extra change part, what's going to happen to our graph? What's going to happen on these ones? It will go below. Yep, because of this -1. And this one would go below because of that -2. Okay, this page we're talking about scientific notation. So what is the standard form of scientific notation? Like, what's the goal? Remember, we want a number with a decimal and then the rest. And then we have times 10 to some power. I'm going to put x. Okay, so remember we're following that pattern. So looking at 35, where do I want that decimal to end up? For scientific notation, where do I want the decimal to end up at?
Right. And since if there were like 3, for example,
So this one, I want the decimal to end in between the 1 and the 9, right? Because I want that whole number, decimal, and then everything else. Okay, I don't want a 0 in that spot. I need a whole number in that spot. So I'm going to have 1.9 times 10. Now we need our exponent. How much did the decimal move? 1, 2, 3, 4, 5. And now we need to decide if it's going to be negative exponent or a positive exponent. Why is it negative? You're right.
because it was moving back.
Right. And because if you think about it backwards, once you have this written right here, is this negative exponent going to get me back to a small number? Yes. Okay, so you can think about it backwards. This negative exponent right here is going to get me back to my small number that I started with. Where do I want my decimal to be for 36? Right now it's right here. Behind the 3. Yep, so I want 3 point, and we want all the whole numbers to be included. So we want 3.09. So now we need to know how far the decimal moved. 1. How many did you get? 4. Is it positive or negative? Positive, yep. Remember, think, is this exponent going to get me back to my big number that I started with? Okay, so remember, if you get lost thinking about it backwards, get your problem and then go the way you're used to. 37 and 38, that's when you're writing it in standard notation. So you're giving the actual number. So I start with 4.76. And then this exponent tells me what? Move 5 in which direction? Yep, right, because it's positive, so I'm going to think I'm going to move in the positive direction. 1, 2, 3, 4, 5. What do I do with the empty spaces? Put zeros. So then we have 475,000. Okay, and the number 38, we have 6. That exponent tells me I'm going to move in which direction? Left, yep. 1, 2, 3. Fill zeros. So we have 0.0060. Let's move on to 39. Do you remember how to multiply with scientific notation? Think of these tens as their bases. Okay, so we're going to basically multiply like terms. So I'm going to multiply 8 times 4 is 32. And then I'm going to multiply these two together. Well, powers of the same base, what do we do with the exponents? Add. -6 plus 6, 0. Anything to the 0 power is? So you have 32 times 1, which is just 32. Let's look at one that doesn't work out that nicely. Let's look at 42. Okay, so same thing, you're going to multiply like terms. So what do I multiply 1.54 with? 6. So we get 9.24. And then what do I multiply 10 to the 6th power with? 10 to the -3rd. What do we do with the exponents? Add, so we get 6 plus a -3, which is 3. So we get 9.24 times 10 to the 3rd. Okay, one more I want to talk about on this page is the dividing ones. Same way, I'm going to look at 40. Same way that we did the multiplication ones. You're going to divide like terms. So 9.6 is going to be divided by 9.82. So 9.6 divided by 9.82. 0.9. Give yourself like 3 decimals. And then what do I do when I divide powers of the same base? What do I do with the exponents? Subtract 2 minus 1? 1. Okay. Can I leave my answer this way? Is it in the correct scientific notation? No. Where do I need to move the decimal? Back 1 this way. So I have 9.77 times 10. I started with the first power. So these problems, I'm going to come up to the top here. If we have a growth, exponential growth, does anyone remember the equation?
Let's start with
Y equals?
MX plus B.
Nope. Y equals, we have A times the quantity 1 plus R to the T.
Yeah, no,
Okay, that's the growth one. Do you remember the difference between the decay one? There's one difference. I think you said it. Yep. A times 1 minus R to the T. Okay, I want to talk about these problems first. What does that A stand for?
Yep.
Amount. Yep, it's the original amount, or that initial amount that you started with. So A is the amount. What does R stand for? You're really close.
Radical. Rate, okay.
Rate. What does rate normally come in a word problem? A percentage. Yep. So that R is your percentage that you're looking for. What do you have to remember to do to the percentage? Change it to a decimal. Yep. So I'm going to make this little note for you. You want to change that to a decimal. And then finally, what does T stand for? Time. Yep. And those variables are the same between the growth and the decay. Okay? There's one more problem we got to talk about. I'll go back to those if you don't have them done yet. It's the compound interest. Does anyone remember this one?
Oh, I hate this one.
This one is the longer one. Okay, this one we have A equals P times the quantity 1 plus R over N to the NT. Okay, let's talk about what they mean. What does P mean? Good guess. It's the principal amount.
Does the A just stand for amount?
A stands for the amount. Yep. A is what you're looking for. So principal amount. R stands for rate, which comes in a
Or
percent, which you change to a
Decimal.
decimal. N stands for that's where the compound interest comes in. That's the number.
Oh.
So if it said it compounded monthly, what would you put for N? 12. Yep. So I'll put compound. And then T is time. Yep. So if it said compounded monthly over 7 years, you would put the 7 in for T. Okay. Questions on those 3 formulas? And again, growth and decay have the same meaning.